from Europe, anybody from South America or from Australia. I usually get a couple of people from India. Anybody from India, it's probably too late in Australia and India anyways. Cool. So I think we should get started. Italy, nice. So Francesco, so we have some people from Italy also, Francesca.
That's very nice. And it's very rare, to find.
Well, it's just because of you then. Your Italian connections are all joining in from Italy. So welcome everyone. This is the QuantUniversity Winter School, and as you all know, over the last 10 weeks, we've been having multiple sessions, all focused on operationalizing AI and machine learning in the enterprise. My name is Sri Krishnamurthy, and I've been hosting these sessions since summer of last year as COVID hit, and we are all destined to be stuck at home and working from home. So we took this initiative to invite eminent speakers, practitioners, academics who've been working on very interesting problems. And we thought that it will be a nice platform to kind of share what we've been learning in the industry, and also kind of bring in thought leaders to exchange ideas. So we started this in summer, and we are very fortunate to have a lot of speakers from throughout the world join in and share their insights, both from an academic perspective and from a practitioner perspective. And we have also been running the summer school, the fall school, and the winter school, and now we're gearing up for the spring school, wherein we have been launching and offering multiple courses. We partner very closely with Premier, the Professional Risk Managers organization. We've also done some courses alongside with other organizations. And as you all know, we have basically had more or less the cadence of having one of these sessions every week. And I'm so glad to see most of you who are joining us from different parts of the world, taking time off from your busy schedules on this Wednesday afternoon session. And I also see many familiar faces, so which means that we are kind of building a habit of learning for you all. So even I was kind of counting over the last close to a year or so, I have learned myself, learning from all these experts from, close to 50 hours of learning through interactions and getting to know them, and also their work and how this has been changing the way the industry works. So I welcome you all to today's session. So I'm very excited to host Dr. Francesca Lazzeri from Microsoft today. Francesca and I got to know each other probably a couple of years back at one of the sessions at NERD, I believe, Francesca, when things were fine and we could go outside. And I remember visiting the Microsoft office, and I could see the beautiful view of the Charles River from the NERD Center and some of the, I forget the specific conference or the workshop which was there, but I got to know her, and I've been observing how she has been evangelizing the whole notion of adopting machine learning. She's also the author of a really cool book, and from Wiley. So Francesca is going to talk a little more about that. And I want to acknowledge all the things she's been doing for the community, and also she is a faculty member at Columbia, wherein she teaches machine learning related topics. So welcome, Francesca.
Thank you so much. It's honestly just a pleasure for me to be here, because as you said, it's really a way to connect with this community of people who wants to learn more. Specifically, I hope that today people are ready to learn a little bit more about machine learning and how you can apply different machine learning concepts to a specific type of data that is time series data. Just to
can I do one thing, Francesca, before we get started? I'm going to make a couple of quick announcements, and I'll share, allow you to share your screen so that you can present it from your screen. I'm going to do like one quick announcement. So let me just share my screen, just so that everybody can give me 1 second. Okay, so just a couple of quick announcements. The first announcement is all the slides you're going to be seeing today will be available on the Q Academy. So for people, I'm going to just post this link on the chat window. So you should be able to, get the slides and follow along what Francesca is presenting today. Thank you for sending out the slides, Francesca. I really appreciate it. A couple of things for people who don't know us. So you are at the Quant University Winter School. So we're based out of Boston, Massachusetts, and we have been doing a lot of training programs. We partner with various organizations and do a lot of interesting programs in the context of operationalizing machine learning and AI in the enterprise. The winter school is still in session. So next week we have Dr. Patacombe from New York University, who is going to be talking about alternative data. So this is primarily for the financial folks who are interested in learning about alternative data sets. And we are also launching the spring school, which starts in April. So if you have any speaker suggestions or you want to hear anybody in particular at the spring school, please type in those names in the chat window or send us a note. We would, depending on the availability of them and how the schedule works, we would love to have them, especially if they're working on something open source related or something cutting edge or research related, kind of aligning with the whole theme of operationalizing machine learning in enterprise. And these are some of the courses we have been offering, and we're going to be all launching these in the spring too, and we have partnered with Premier to offer these. I'm particularly excited about the algorithmic auditing course and also the risk in machine learning course. We have had a lot of interest from various practitioners in the financial industry take these courses, and we just got off a call with a large entity who are eager to send 15 people from their whole organization to get trained on how to review the risk of various machine learning models. So if you or your enterprise is interested in learning more about these, please reach out to us. We'll be able to happily share more information with you. And also, if you are interested in taking any of our other courses for primarily geared towards financial professionals in the context of model risk or AI and machine learning for finance, or even just a basic introduction to data science in Python, you can register at QuantUniversity.com. And as I mentioned today, we are going to be having the rest of the session listening about various aspects of machine learning and time series modeling with Python. So I will hand off the stage to Francesca so that she can orient us with like what does it mean to build machine learning models. And as you all know, I also teach at Northeastern University as an adjunct professor. I teach primarily data science and machine learning related topics. One thing I've realized is there are so many tools available which will help you kind of put things together and start building programs. Now, the biggest challenge is how do you contextualize it? And that's where some of the tooling Microsoft has put together is going to come in handy. So Francesca, you have the stage now. So please feel free to share the screen, and we would love to kind of listen to your lecture.
Absolutely, thank you so much. And all this information that you just shared, Sri, are extremely interesting also for me. So I will try to join also future lectures and webinars. So let me start by sharing my screen. Let me know when you can see it. And
yes, we can see the screen now.
Perfect. And I will start also in this presentation. Perfect. So first of all, again, thank you so much for the invite. I'm glad, to meet all this community of people who wants to learn more about data, quant, and also in general how to apply machine learning to different typologies of data. So the presentation of today is going to be about machine learning for time series forecasting with Python. My name is Francesca Lazzeri. I have been now working at Microsoft for about 7 years. I started my career as a data scientist. I was working for a machine learning team, and then I also worked a few years for the AI research team, and now I'm in a team called the Cloud Advocacy team. And I lead a team of about 15 engineers, and we build end-to-end solutions for customers, of course, on the cloud. We specifically target customers from the education academic sector. So we work with a lot of faculty researchers that wants to use, again, the cloud in order to build their solutions. I do have a few engineers who focus on machine learning with me. me, because I'm one of those. And then I have the rest of engineers who focus on more like AI, advanced analytics, big data, but also IoT, for example, and also web and app development. So it's a really diverse type of a team, and we work again with the external customers at Microsoft. As she mentioned, I also wrote a book this year that is about the topic of this session, that is machine learning for time series forecasting with Python. Because what is interesting is that every time that we start to think about machine learning and also AI, we think about specific use cases such as image recognition or custom vision or text analytics, which are all excellent examples of machine learning and AI for sure. But what we forget sometimes is also a specific type of data, that is time series data. And what is nice is time series data honestly are everywhere in machine learning, in AI, and also they are from different typologies of industries. If you think about finance, if you think about marketing, but also IoT type of scenarios, they all have these components, this time component that is really shaping their data set. And when we think about machine learning, there are a few things that as a data scientist and the machine learning practitioners we need to do in order to apply different machine learning models to this type of data. So here there is just an overview of the book, and again, it's not a too long book. It's about 250 pages, so it's more like a big book that try to give like an introduction to time series forecasting with machine learning and with Python. So it's a very applied type of book. It's not a book that tries to explain you the mathematical foundations of machine learning or of time series forecasting. I say in the book in the introduction that I hope that people are going to gain that type of knowledge from different manuals, from different tutorials. But this is really more a book about, okay, how you can use your time series data and how you can apply Python to that type of data so that you can get started and build your solution. What I'm planning to do today is just to give you an overview of a few chapters of this book. Of course, we do not have too much time, also because at 1 Boston time, I do have a hard stop, unfortunately. So I selected just a few topics from the book. And then, of course, if you wanted to connect offline, if you had specific questions, please feel free to let me know also through Sri, and we can organize, other focus groups or other webinars where we can go in a little bit more detail on some of these concepts, because again, there are a lot of concepts that I cover in the book. So the agenda for today is I want to give you again a sort of introduction to time series forecasting from a machine learning perspective that I think it's very important. Then I'm going to talk a little bit more about different autoregressive method for time series forecasting, and something that I'm not going to mention here, even if I put it on the agenda, but I want just to give you like an overview, is that in chapter 4, when I introduced these autoregressive methods that are more from the classical family of methods, of techniques for time series forecasting, I also mention, I also show many different examples and ways that you can use in order to apply automated machine learning on time series forecasting. Then I will also give you a general overview of deep learning for time series forecasting. Specifically, we will look at recurrent neural networks. And finally, there is also an overview in the book on how you can build and deploy your time series forecasting model. I put 55 minutes there, not because, of course, it's going to be the time that I'm going to use to show you how to build and deploy your time series forecasting model on the cloud, but it's more the time that you should take if you complete some of the exercises that are related specifically to deployment of time series forecasting models. And I'm going to share with you also a GitHub repo where you can see all the code, and you can try this code offline, either with a sample data set that I use for this sample, or with your own time series data. So in terms of introduction to time series forecasting from a machine learning perspective, as you know, And also, as I mentioned at the beginning of my presentation, time series forecasting is a very important area of machine learning that is often neglected, I would say. It is important because there are so many prediction problems that involve a time component. These problems are not really well considered sometimes because it's actually this time component that makes time series problems more difficult to handle, if you want. And in this lesson, in this overview, I hope that you will discover, first of all, what is time series forecasting. I'm sure that many of you already know, but what makes time series data so special, and then what are the different Python packages and libraries that you can leverage in order to handle time series data, and also to build some of the machine learning models that I explain in details in the book. So, as you know, a machine learning data set is a sort of a collection of observation. Time does not really play a specific role in a normal machine learning data set. Like, for example, if you have to distinguish between different images and you want to classify those images between a cat and a dog, for example, you don't really need to know when this observation was made. Like the algorithm that you're going to build with Python is going just to recognize the different images, and is just going to give you an output that is a sort of a prediction between the two categories. In this simple example that I use again is either cat or dog. However, a time series data set is different because there is this time series information that adds an explicit order dependence between the observation that you're going to deal with. This is called a time dimension. And this additional dimension is both, I would say, a constraint, but also a structure, what we call in Python an index, that actually provides a source of additional information. And there are many techniques that you can exploit, that you can leverage in order to get this additional information and improve your machine learning models. And I explain this a little bit in more detail in the book as well. The other big concept that it's important to know is that, again, there is a very different definition between what we call time series analysis and what we call as a time series forecasting. In this case, we have different goals depending on whether we are interested in understanding a data set or making predictions. And it's really in the part that is about making predictions that machine learning is extremely important, is extremely helpful, because again, it's going to help you making the prediction part. So understanding the data set, that is called most of the time series analysis, can help make better predictions, but is not required and can result in a large technical, I would say, investment from your team in terms of time, but also expertise. And most of the time, again, time series analysis is also is just related to the analysis of the data. So this involves developing models that best capture or describe and observe time series in order to understand the underlying causes, the underlying reason. And this field of study, that is again time series analysis, seeks the why behind the time series data set. Time series forecasting, on the other hand, is about making predictions about the future. And this is sometimes called also extrapolation in the classical statistical handle of time series data. And the more modern fields, such as I would say machine learning, focus on this topic and refer to it as time series forecasting. Most of the time, I would say also always, forecasting includes taking model fit on historical data and then using them to predict the future observation. And so it's important to also understand the two fields of study, which are extremely important, both of them. But again, the book and what I'm focusing on is more like time series forecasting and more on how Python and machine learning can help us building time series forecasting solution. Another important distinction to make is is how you need to shape time series data as a supervised learning problem when you decide to, first of all, build a time series forecasting solution, and second, to apply machine learning algorithms to your solution. So in this case, I give just a simple example on how a simple time series data set, as you can see on the left, you have a sensor ID. Let's say that we are in an IoT scenario. Then you have the timestamp, which is your time dimension, and then the value. So here, as you can see, you have to use what we call the sliding window. And you can do this easily in Python, and I show the different examples also in the book. And you need to make your time series as a multi-step supervised learning. In this case, again, because we have a value 1 that we need to predict. And what you're going to do then is going to be the next, and you're going to, in the next timestamp period, and what you're going to leverage is actually the historical data that you got from your original time series data set. The same is also for simpler problems, like let's say that you're not in a multi-step time series forecasting problem, but you are just you just need to predict the variable. In this case is variable y, that is a value 1. You need again to predict that, and you're going to use this sliding window method that is going to help you to leverage again historical data from the same variable, and then you're going to use this historical data to make a prediction. And this is again can sound like a very simple concept to understand. However, sometimes when I work with a data scientist, but also with a business expert, data expert, it takes a while to understand that again you need to do some additional steps in order to prepare your data and make sure that your data, your time series data, is ready for feeding the machine learning model. And later in today's presentation, so you will see that this is the same when you apply deep learning models. There is a data preparation step that you need to perform in order to make sure that your data, your time series data, is ready for the modeling step. In the book, I also focus a lot on Python because again, it's a type of a book, more like a textbook. It's more like a very applied book. And in one of the first chapters, I introduce all the Python family for time series data. I start with SciPy, that is this ecosystem of Python libraries, and then I introduce NumPy, a Matplotlib. These are SciPy libraries that provide a foundation for most of the things that you need to create with time series forecasting. And then I also introduce a Panda, stats models, and scikit-learn. These are more like high-level SciPy libraries that provide the key features for time series. Again, in the book, I show examples of all of these libraries and how you can introduce and also how you can actually deal with your time series data before even the modeling phase. When we think about one of the first, I would say, libraries in Python that you need to use for time series forecasting, we immediately think about Pandas. And again, Pandas is not the only libraries and package that I use in the book, but is the first one because Pandas is great at capturing 4 general time-related concepts, as you can see from this table. There is the date times. This is a specific date and time with the time zone support. So this is again great when you need to deal with your time series data. There is what we call the time delta. This is an absolute time duration. There is a time span. This is a span of time defined by a point in time, and it is associated with frequency. And then there is the date offset. This is a relative time duration that respects a calendar arithmetic. So this is again something that you can leverage when, for example, you want to deal with different seasonalities in your time series data. In the book, I also show you like the first few steps that you need to learn in order to get started with machine learning for time series forecasting. Like, for example, you can easily leverage pandas to load your time series data set from a CSV file, even if you're not using, the cloud to store your data. If you want really to start from scratch and you want just to upload your CSV file in your Jupyter, for example, environment, you can easily do that with pandas. Then I show you how you can pick up the loaded data and querying using datetimes, leveraging some of the concepts that I was showing in the previous table. And then also how you can calculate and reduce summary statistic. That is, again, it's a fundamental step before the modeling part. And then how you can also perform some of the most important feature engineering steps for time series. Another important concept, and I think I concluded the book with this, is being able to build an end-to-end forecasting solutions, because I think that a lot of the tutorials out there and also of the textbooks out there, they are great at explaining the modeling piece, which is, again, for data scientists, data analysts, it's extremely important. But when you actually work in the industry, you need to learn how to develop an end-to-end time series forecasting solution and any typology of machine learning. So when we think about AI and machine learning, it's not just about the modeling piece. Of course, the modeling piece is extremely important and you need to spend a lot of time on that, but it's also important to learn how you can deploy your time series forecasting model. And this is one of the concepts that I explain at the end of the book. Again, once you have picked the best model for your solution, for your time series scenario, how you are going actually to deploy it. And I also introduced this concept of, the time series forecasting cycle, development cycle, actually, that starts with the business understandings. Of course, business understanding is really related also to data understanding, data preparation, and we see this specifically in chapter 3, that is all about how you can use Python in order to prepare your data and also perform additional featureization for your data, and then the data modeling phase, that of course is very important, and finally the business validation. Because again, this type of I would say more like templates that are helping you developing this solution from the business understanding to the business validation, then are going to be very helpful when you build an end-to-end architecture on the cloud. This is, again, it's one of the images that I built also for the book. We use an energy demand forecasting scenario for the book, and I show you how you can collect data from power grid and IoT data generators, then how you collect the data, explore these raw data and try to clean them, and also you apply feature engineering that are specifically for time series data, and then how you can process this data, create a model, deploy this model as a web service, score this model, and eventually retrain the model, and then consume these forecasted results, most of the time from a friendly UI. It can be a dashboard, it can be a report, it can be something that, again, the experience of consuming those results is going to be nice and user-friendly. Again, it is to give people like an end-to-end understanding of what time series forecasting actually means. Then, in terms of autoregressive methods for time series forecasting and automated machine learning, so as you know, there are many different methods. Here I listed 11 different classical time series forecasting methods, and they're not even all of them. As you can see, most of them, they are more defined as a classical time series methods, and later we also are going to get an overview of deep learning applied on time series type of data. data. So in the book, of course, I do not go through all of them. I just focus on the autoregressive ones. So it's more like autoregression, moving average, and most importantly, ARIMA and ARIMAX. So from the autoregressive moving average, I go to the autoregressive integrated moving average, and then I show how also to apply both the SARIMA and SARIMAX. So these are all autoregressive models that are extremely important. And I would say most of the time data scientists, they start with these models, with these algorithms, and then they move to a more like a deep learning type of approach. These are more like a traditional time series forecasting model. And if you think about the ARIMA ones, that is the sense for autoregressive integrated moving average, what is nice is that it's actually based on two different models, the autoregressive model, also AR, and the moving average model, MA. There is also this I between the AR and the MA, and that I stand actually for integrated. So the autoregression, this is again is a model that uses the dependent relationship between an observation and some number of lag observation. Then there is the MA on the other side, that is the moving average. This is a model that uses the dependencies between an observation and the residual error from a moving average model applied to lag observation. And then, as you can see, there is this I. So this stands for integrated. So this is the use of differencing of raw observation, for example, subtracting an observation from an observation at previous timestamp in order to make the time series stationary. And each of these components are explicitly specified in the model as a parameter. So you need somehow to get an understanding of all these components, because then when you're going to leverage the Python package that we will see in the example, you need to somehow define these components. And each component has a specific role, because again, it's a sort of a parameter with a standard notation. You can see these here. There is the P, the D, and the Q. And when you're going to use Python, again, you have to define the P, the Q, and the P, the D, and the Q. So the P is the number of lag observations that are included in the model, and this is also called lag order. Then there is the D. This is the number of times that the raw observations are differenced, also called the degree of differencing. And finally, there is the Q. This is the size of the moving average windows, that is also called the order of a moving average. And I would say that a linear regression model is built including the specified number and type of terms, and the data then is prepared by a degree of differencing in order to make it stationary. So this is, again, it's important. So for example, you need to remove a trend and different seasonal structures that affect in a negative way the regression model. So what does it mean in terms of Python? Python, it's very, very nice, because we have this ARIMA model that can be created using what we call the SATS model library in 3 different simple steps. And I explain this also in the book. So you need to define the model by calling this ARIMA, and you need to pass in the P, the Q, the P, the D, and the Q parameters. Then the model is prepared on the training data, and you need, of course, to call the fit function. And finally, the predictions can be made by calling the predict function and specifying the index of the time or times that you need to predict in the future. Here, I also added some of the resources that I use in the book as well. So you can see the ARIMA API and the different also APIs for ARIMA results. Another important aspect that, again, I dedicate a lot of time to it in the book is related to deep learning for time series forecasting. And at the end of this session, I hope that I will have sometimes also to show you where the GitHub repo is and how you can get started with some of these examples. So after that, I introduced the autoregressive models. Another important aspect, as I was saying, is the application of the deep learning models to time series forecasting. And this, again, you can do these with Python, which is great. Specifically, we're going to see how you can apply recurrent neural networks to time series data. So first of all, as you know, it's important to understand what's the difference between classical machine learning and deep learning. There are many different aspects of it. You know that the deep learning is just a group, a typology of machine learning, and there are a few aspects that you can use in order to distinguish between machine learning and deep learning. I know that probably this audience, this group of people already is very familiar between the differences, but it's always nice to to explain it in a very simple way. First of all, in terms of data points, most of the time when you have a lot of unlabeled training data, you can use a deep learning to make, again, concise conclusions, while with machine learning, you can also start with a smaller data set. There are many different hardware dependencies, but also the featureization process is different because machine learning requires features to be identified and created somehow by users, specifically supervised learning. In deep learning, you can let somehow the algorithm to learn from these high-level features, and the data. The algorithm can learn from the data and can create its own high-level features, and then can create new features by itself. The learning approach is very different because machine learning divides tasks into small pieces and then combine the received results into one conclusion. The deep learning approach is actually much more sophisticated and complex because solves the problem on the end-to-end basis. And then also in terms of execution time and output, these again, you need to expect different typologies of outcome. The nice things of deep learning is that the output can be anything from a score, a text, an element, or a sound. So one of the questions that I get most of the time is why I need to apply deep learning to time series forecasting. Why recurrent neural networks? So honestly, recurrent neural networks has been shown to perform very well in many different scenarios. These are just some of the scenarios that we have been observing from public data set, but also from working with the data. It is a very flexible model, and most importantly, can learn from big data. And this is something, again, that we have been observing for a while now on different customer scenarios and with different types of data set. It's important, of course, to understand also what happened inside an artificial neuron. So if we zoom in further, how does this neuron process actually works? As you can see, there is each input actually in a deep learning neuron actually get scale up or down. So when a signal comes in this case, when I say signal, I mean input, so input data that you use for the modeling piece. And so when this signal comes in, it gets multiplied by a weight value that is assigned to it, to this particular input. So for example, in this case, this neuron has 3 inputs, and then it has 3 weights that can be adjusted individually. And during the learning phase, the neural network can also adjust the weight based on the error of the last test result. So this is again what makes sometimes artificial neural networks very good with any type of data, but also specifically for time series data. Then you can see that in this step, that is more like the bias step, there is an offset that is also added to the sum. And this offset is called bias. So the neural network also adjusts the bias during the learning phase. And this is really the moment in which all the magic happens, in my opinion, because at the start, all the neurons have random weights and random biases. And after each learning iteration, weights and biases are gradually shift so that the next result is a bit closer to the desired output, to what you want to predict. And this way, the neural network also gradually moves towards a state where the desired patterns are learned. Finally, there is the activation. So this is the results of the neural calculation that is turned into an output signal, is an output results. And this is done by feeding the result to an activation function that is also called transfer function. So I introduce these simple concepts because I think are extremely important when then we try to apply more complex concept to time series data. There is this concept of backpropagation through time that is again an essential concept in recurrent neural networks. Recurrent neural networks is more like a class of neural networks where connection between the nodes from a form a sort they create a direct graph along with a temporal sequence. So as you can see, there is this temporal sequence that we will understand better soon, because and this is important with the time series data because this allows it to exhibit the temporal dynamic behavior. So you can see that here what is also nice is not just the forward through entire sequence of in order to compute the loss, but is also going so not just in one direction, but is also going to the other direction. So then backward through the entire sequence again to compute what we call the gradient. And again, this has been like extremely successful for time series data, because you can again see that how the simple feed-forward neural network is working, and then how actually there is the recurrent neural network that is working, how the structure is actually working, and is actually working very well with the time series type of data. Recurrent neural networks are also great because they remember the past, and it's actually their decisions are influenced by what it has learned from the past. This is different from the basic feed-forward networks because they actually remember things too, but they remember things they learn during the training, while the recurrent neural networks learn in a similar way while training. In addition, they remember things learned from prior inputs while they are generating also the output, the results that you want to get from your model. So just to give you a little bit more information on how this is working for time series type of data. So recurrent neural networks are different from feed-forward neural networks because they have this feedback loop that is connected to their past decisions, and they're ingesting their own outputs moment after moment as a sort of input. I have to say that often you can hear that recurrent neural networks have what we call the memory. So adding memory to neural networks has a specific goal because there is this information in the sequence itself, and the recurrent neural networks use it to perform tasks that, as I was saying before, the feed-forward networks can't perform. So this is this SQL information that is somehow preserved in the recurrent neural networks hidden state, what is called hidden state, and this is somehow the neural network managed to span many timestamps as it somehow share this knowledge forward and try to affect this processing for each new example. When you think about recurrent neural networks and how you can apply them to Python, to your time series data through Python, it's nice to know that there is a Python package for all of these. This is again called sequential, and in Keras, which is one of the framework that you can leverage, Python framework that you can leverage in order to build your time series forecasting solution. And again, if you wanted to apply deep learning models on them, these parameters units are basically our dimension of this hidden state. And in Python, again, you have different packages and libraries that you can use to quickly build your deep learning solutions for time series forecasting. As you can see here, I put like a very simple model, and you can also use different topologies of activations. Here in this simple example, I'm using the softmax activation, but there are also different options that you can use, you can leverage. The last things that I want to say about recurrent neural networks, and then I would love to introduce the more applied use cases, is that it's really because of this feedback loop that occurs at every timestamp in this series. Each hidden state in the recurrent neural networks contains pieces, not only of the previous hidden state, but also of all of those that have been prior in the prior states, as long as the memory can persist. So you can understand that it's really this structure, this mechanism that makes recurrent neural networks very useful for time series data. Now, let me introduce a little bit the scenario. As I mentioned before, energy load forecasting is the simple scenario that I use also in the book, just to show some of the Python applications to time series data. The scenario is important, but of course it's not the goal of the book itself. The book itself is more like an overview of the different Python packages and the different techniques that you can apply to time series data. But again, as an example, we use the energy load forecasting one. There are many differences between what we call the short-term load forecast and the long-term load forecast. For this specific scenario, we are going to use the short-term load forecast because, again, it's a data set that is using hourly data, and also the type of prediction that we wanted to do is actually next hour. So as you can see, the data granularity is hourly, and there are quite amount of data. We used about 3 years of data, and then as you can see, we produce every hour. The forecast frequency was produced every hour or every 24 hours. But for this specific use case, we decided to produce it every hour. The energy load forecasting is actually a very interesting forecasting scenario because energy grid operators need to forecast the load to ensure that they can balance supply and demand. So the next step after forecasting is more like an optimization type of problem. I would say it's the first problem that you can you need to work on in order to optimize supply and demand. And this can be applied to many other scenarios, from finance, from sales forecasting, from marketing. Again, I really love the energy load forecasting because it's a scenario that can be generalized to many other scenarios. So in the short term, operators can manage resources by increasing or decreasing the supply of electricity on the grid. And so this is, again, it's a nice scenario to use as an example. And then the data that we use is a public data set that was actually used also in the GEF.com 2014 competition for energy load forecasting. Just to give you a little bit more understanding of the data set, we have about 26,000 hourly load values, and the seasonality that we observe is annual, weekly, and daily. Keras, again, is a package that is an API that we decided to use because, again, it's great for deep learning type of scenarios. It simplifies syntax for common deep learning tasks, and it operates over efficient backends such as TensorFlow, CNTK. For this specific scenario, we use TensorFlow. And then there are less control over low level operations, which is not great, and sometimes it's not as efficient as other frameworks. But overall, Keras was a great choice. And also for you, I really recommend that you decide to use Keras because, again, it's a great choice for time series forecasting type of scenarios. The experimental setup As always, we decided to divide the data set into training, validation, and test data set. Specifically, we use the train for model training. That was the data set that contains no information from other data set, of course. Then validation, most of the time, you want to have also validation data set because you can use it for testing different model hyperparameters. And then we use it the test to evaluate the model and compare it to others. Before I jump into the data preparation, which is a very important step for a deep learning type of solution. I was just checking the time, yes, because I just want to share with you also all the resources that you can leverage in order to get started with these. So Sri, do you want me to jump into the resources, or you want me to go through the data preparation?
I think we have like 7 more minutes, Francesca. So maybe, how about we still have a couple of questions also?
Sure.
I was wondering, if we go to the resources, I know the slides have been shared. What we could do is, and you and I can coordinate offline and maybe record like a quick to the video once you get a little bit of chance. And then I can augment that video with where we leave off now. That way people can extend that discussion. I don't want you to be rushed at the end. I know you have one of the hard stop.
Absolutely, this works for me. And honestly,
so two things. One is
can you hear me?
GitHub link. Also do is which are publicly available. So what we do is we could share these notebooks through the sandbox. Also, we have a sandbox so people can just fire up and launch it. So that's one option. So we could I can work with you and people can run through the notebooks. The second thing is I hope that the case study which you're presenting is also something we could also play around with. So do you want to just move to the question now?
Yes, that works for me. Can you still hear me? Perfect.
Yes, we can hear you. I was saying, can we move to the question answer section now?
Yes, we can.
Okay, so we have a couple of questions.
Perfect.
Okay, so the question, one question is, how do you see
unfortunately
these Python?
Unfortunately, Sri, I cannot hear you.
Traditional series packages, can you hear me?
I cannot really hear you very well. You are breaking out a little bit. So can you repeat the question?
Okay. Yeah, so the question is, how do you compare traditional econometric software packages like eViews to that of the approaches you're using and machine learning based approaches?
Yes, so this is a wonderful question. I would say that it depends. It depends a lot on the type of data and the type of the scenario that you are trying to solve. Most of the time, using a similar type of metric to evaluate your models is also very helpful. Of course, not for all the scenarios, but for most of them. And for example, you can use what is now very popular in the industry is the MAPE, mean absolute percentage error. And so using the same metrics across different algorithms and across the different packages that you are trying to apply can help, because then you're going to have a consistent output from the metrics and you can compare. I would say that the accuracy of time series forecasting model is not the only thing that you should look at. Sometimes there are other factors that you need to take into consideration, such as like the performance, such as the GPU versus CPU. Again, this is more like the type of hardware that you are using, or like the virtual machines, the different compute targets that you're using. So also making sure that your end-to-end solution is actually working very well. And based on all these considerations, again, you can decide if you want to use some more like a classical type of approach, or use like machine learning at the cloud in order to use your solution. So going back to your question, I would say if you are asking these questions specifically from a model algorithm type of performance, I would say that if you can use a consistent metric to evaluate your models, that it's a good starting point. If you're asking this more like from an end-to-end architecture or solution for your time series forecasting models, I would say that you need to evaluate a lot of different factors, such as the size of your data, the type of memory that you can use, the type of virtual machines and computer target that you're going to use, but also how you're going to deploy your solution as a web service, and how you're going to refresh, how often you're going to refresh your data set. So these are all considerations that, again, you need to take into consideration in order to make a final decision. Great. Shri, unfortunately, I cannot hear you anymore. I don't know. Let me see the chat. I don't know if other people are able to see you or to hear you. Let me see. No, unfortunately, I cannot hear you. And I know that we are at a time, so I think that Shri probably is experiencing some technical difficulties, which is totally fine. I would love again to thank you all for listening to this presentation. I hope that I was able to give you a general overview of what machine learning can do for time series type of data, and specifically how you can leverage Python to build your machine learning solution for time series data. Honestly, it was just a pleasure. I'm always happy to meet, different people who work in the same field. So I hope that we will be able to meet also in the future. Thank you again, and talk to you all soon. Thank you.
Thank you so much, Francesca. This was an excellent presentation. Sorry about the last-minute network issues. As I mentioned, we will, regroup, and we will talk, kind of put together the last part of the video. So for people who are, continuing to join us for the next few sessions, so as I mentioned before, so the slides will be available through the Q Academy. Put together video school. So I hope you enjoyed this video. So thanks again for joining us in today's session, and I will see you again in another week. Next week, we'll have Petacombe talking about generative data sets, and enjoy the rest again. Bye.